Hello, this is Dr. Brian Fath, is a professor of biological sciences at Towson University in Maryland, USA, where he teaches ecosystem ecology, environmental science, human ecology, and sustainability. He's also a senior research scholar at the International Institute for Applied Systems Analysis in Luxembourg, Austria, co-editor-in-chief for the Journal of Current Research in Environmental Sustainability, co-author of recent books, Foundations for Sustainability and New Ecology, A Systems Perspective, and a founding member of the Research Alliance for Regenerative Economics. Dr. Fath is going to talk about his top 10 measures of systemic societal health. So welcome to our podcast, Dr. Fath.
Thank you, Sally. It's a pleasure to be here.
So you and your college are using network analysis methods that help assess health in ecosystems to assess health in human systems like economies. So why should this work? Why should anybody believe this?
Okay, yeah, good place to start. Well, my background is in systems ecology, and particularly using network methods, and so that's how I got into the connection here. And network methods have been around for quite a long time. I know there's been a recent surge in activity networks, which is wonderful. My PhD advisor is actually doing stuff in the early 70s on trying to understand how energy flows in ecosystems, and so it comes from an ecological background of building essentially trophic networks of who's eating who in food webs and where the energy is flowing. That, of course, can then be expanded to where the nutrients are going or where the water is going or any conservative quantity. But so it's this approach that allows you to see the whole system simultaneously and the effects there. What really attracted me to the entire approach was this idea of looking at indirect effects and knowing that a system is more than than the sum of its parts. And if you only looked at direct pairwise interactions, you're going to be missing a lot of what's going up downstream or cascade effects or whatever the way you describe it. And so these network methods that we have been developing for the last 40 or 50 years in ecosystem studies are now being applied more and more to socioeconomic systems. And I think there's a couple of good reasons why we do that. One is because ecosystems just make a great template for sustainable systems. They've been around for a long time. They have evolutionary dynamics that have made them able to deal with all sorts of different situations and be adaptive. And so this whole idea of kind of building more eco-mimicry into our system seems to be a wise thing to be doing. And then, understanding that social systems are also networks. There's networks of trade, there's networks of exchanges of financial between sectors, there's social networks. And so the network methodology is kind of universal in that sense, that you can take it to across discipline that way. And it's fun to be interdisciplinary, right? We get to meet a lot of different
I suppose. Part of my background is in the social sciences, and the other part is in engineering. So I've been very interested in how do you explain it to the social scientists, why this makes sense. And for me, one of the things that's been most helpful is the idea of just, instead of calling them ecosystem or ecological networks, calling them flow networks, because that's what the common thing is that you're studying how things circulate and it's information and resources, and the fact that a flow network is basically something whose existence depends on these flows really changes the way we see both societies and economies. So here economies become metabolic networks, and they're very much they're the same kind of energy processing and information processing systems that all have to have these parts that all work together. And so in that sense, it's kind of not too surprising that the same kinds of approaches that talk about sustainability and resilience and regenerative circulation in ecosystems also work in human systems.
Right. No, I agree. And I mean, I think you're credited with the coining the term energy network science, right? So it's more general than that. And again, maybe that's another point to stress, was where, what I like about the science background is the reliance on first principles and knowing that the laws of thermodynamics are behind what's going on, and the periodic table and the actual matter and the physical flows that are there. So you can boil it down to, as you said, flows of something.
Yes.
That are going along these networks, and then that these are conserved quantities yeah, so that all helps that kind of cross-discipline approach that we have.
Okay.
So I'm all for calling them flow networks.
Great, thanks. um, you have also done a lot of work with resilience, particularly, I believe, in your applied systems analysis in Luxembourg.
Mm-hmm.
So can you tell us a bit about what is resilience and how do you measure it in human systems?
Yeah, I mean, resilience is one of those terms that has become probably overused, that it's lost a lot of meaning, and almost like sustainability these days as well too. But they're well-meaning, and they're important concepts, so we don't want to lose them. Resilience, at least in the ecological literature, where it got a lot of its start, was with the idea of a system able to kind of return to its attractor state after some disturbance, and so the idea of bouncing back to some previous state. Of course, now we know that most complex adaptive systems have multiple stable states, and so they don't always have to return. Other people would define resilience in terms of, more like a resistance factor, like what keeps it where it is in the first place, even though a resistance system might actually be brittle once it breaks and has no chance to return. Once the bridge breaks, it's not going to come back to the way it was before. So taking all those different considerations into effect, we published a paper a couple of years ago where we were looking at resilience as defining it in terms of this adaptive cycle that was already out there. Buzz Holling had presented this idea that all systems go through a 4-stage dynamic process where they go through a growth stage, they go through kind of a conservation equilibrium stage, and then they go through some sort of disturbance collapse phase, and then a reorganization phase. And so we see this in nature. We see it in the seasons, that you've got these different phases of life, and that and so we just proposed, that to be a resilient system, it has to be prepared to deal with all 4 of those phases. It has to, and again, in some sort of most anticipatory sense, that that one phase that might seem 3 steps away, you need to be preparing for it now. And so we were making just some insights into at each stage what you should be thinking about at each of the other stages, even though you're not there yet. And so essentially our definition of resilience is ability to successfully navigate this adaptive cycle. If you can navigate it and keep navigating it over and over again and be prepared for these cycles that are coming, then you're going to be pretty well off. So
how would you measure that in a system?
Well, you can observe it taking place. Whether it's where you are in this, and again, one of the interesting things is that the most of these systems that we're dealing with, especially like a city or a society, is complex enough that it has multiple things going on at the same time. So scales, right. So the cycles are happening at multiple scales simultaneously, and so you might see some parts of the system that are actually coming into collapse, and other ones that are going through the regrowth, and so you're just kind of keeping an eye on that. What's interesting about COVID is that it kind of cohered all the systems together, that we all locked down together more or less, or that we all. So there's more of a global scale impact. I actually had some colleagues look at applying this model to specifically like the COVID response in certain countries, and seeing if they could model it along those terms, and basically then saying like, okay, well, now we're in the collapse phase. Like, how do we come out of this? So yeah, it's a ripe area for research. That's for sure.
It's interesting. Okay, so from my engineering background, I was thinking more in terms of, like number and diversity of roles, so that you have fallback positions. But I understand that's a relatively simplistic first pass version of what resilience is.
Well, it's part of it for sure, right? And so we can get into that with some of these different 10 measures. So resilience is, I think, a bigger piece of that. So when we're talking specifically about these measures of systemic social health, that we have these particular indicators, and several of them together could probably be aggregated to make a resilience indicator. But we don't have just one resilience indicator that we're measuring, at least in this work that I think we're describing now.
Okay, so that brings us to the other part of it, which is the regenerative circulation, which is, again, something that seems to be essential. So can you define a little bit about what makes circulation regenerative, and how do you measure it?
Right. So this idea of flow networks, right? So there's always some sort of circulation going on. There's always some currency flowing between the different nodes in this network, and the circulation aspects are really the again, back to first principles, that you need to have obviously healthy inputs, renewable, reliable inputs that are driving the system. So if, I think it's the first law of sustainability, basically, that if you're building a system structure on non-renewable resources, it's going to collapse eventually when those non-renewable resources run out. I mean, Herman Daly and others have said this for decades. So having reliable inputs, renewable inputs, to keep that circulation going, and then whatever system is generating the outputs, those also have to be able to be absorbed by the system and not overwhelm the system, and be healthy in the sense of not fouling the nest. So in the most basic sense, the circulation is just the input-output flows that are going through the system, and I think those are easy enough to assess. Do we have renewable resources, and are they polluting the environment? And that's a good first place to start. But on top of that is this idea that within the system, there's multiple scales. Again, back to that concept that every level in that hierarchy needs to be able to access the resources that it needs. So you might have a core part of the network that is resource rich and has strong flows and the heavy flows and the large banks, or so to speak. But you have a periphery that is reaching out to all the individuals. And so the local banks also need to have flow reaching to them, and you don't want to cut those off. They're not going to have as much flow going through them as the ones on Wall Street, but they have to be still maintained. And so this idea of cross-scale circulation is just making sure that every part of the network is receiving kind of the appropriate flow for its scale that it needs. And then on top of that, the fourth circulation property that we are addressing here is about kind of resource reuse or recycling, and that in an economy, it's essentially the amount, like the multiplier effect. So when you spend $1, how many times does that stay in the system before it gets somewhere else? And in ecosystem flows, we have very good measures, cycling indexes that we can use to just basically track how much of that flow is cycled and being recycled. And so we again, a lot of emphasis on things like circular economy, obviously resource reuse, recycling. And so it's a very, I think, easy message to make that's an important factor in any system to want to have high reuse. And we refer to it as regenerative reinvestment. So it's essentially keeping it going, not letting it get away, right? You have something, the resource is there, you reinvest it, you recycle it, reuse it within that system.
Right, to keep it, basically you're making sure you're maintaining all of the internal parts, so that keeping them nourished all the way across.
Yeah, absolutely. Most of the cost of maintaining a complex society is just maintaining the complex society, right? And so we see that early stages of a system development, again back to this adaptive cycle, there's probably additional kind of surplus flows that can be used to grow the system, to build structures, to build new complexities. But then we see that as the system complexifies and does what it needs to do, the energies that it has are essentially maintenance energies, and we tend to see growth leveling off at those points. And so it's a natural system response for a system to not grow as fast at the later stages as it did at the early stages.
Right. Okay, so economists have been trying to figure out how to measure systemic health forever and ever. How do these measures that you're trying to implement differ from the classic measures like GDP growth?
Right. Well, GDP is, I think, rightfully criticized by a lot of people these days, which is good. I understand the attraction of a single metric indicator, and one that more or less people can agree on what goes into it, so that if two people were to calculate it, they would come up with more or less the same number, although not always. But of course, it includes a lot of things that shouldn't be included. It doesn't include other things that should be included, and it really only focuses on economic flows and not on ecosystems or social dimensions. And so I'm encouraged by the well-being indicators and Genuous Progress Indicator and the other ones that have been developed out there. So ours, I would say, is in the line of those other multidimensional indicators. Again, recognizing then a lot of the answer that you get can come down to what the weightings are that you have, and what you decide, what basket of goods do you want to put into your indicator, and that could be different depending on the different objectives. And so our first pass was looking at these 10 principles of regenerative economics, and I had mentioned some of the things that had to do with circulation. Some of the other indicators have to do with kind of the structure of the network itself, the design principles or the design that has come out of that, and then the relationships that are there. So it's a list, right? Is 10 the perfect number? Maybe not. Maybe it's 9. Maybe it's 12. But we're starting here with this list, and again, what it I think, where it complements, it's not only multidimensional as opposed to GDP, but it definitely has a stronger holistic approach because it's network based, and it has a more first principles based with the energy flows, and it has a stronger connection to the ecosystem, which obviously is pretty ignored in GDP. So, let me give you some of the other examples of. You had mentioned the diversity of of like an ecosystem. We know is an important factor, and you can also use similar type diversity measures to measure the diversity of an economy, like how many different niches there are, how many different roles are there, and a more diverse economy would have signs of healthier resilience, we could say, or ability to regenerate, because there's more options there. We've actually had some interesting work recently on looking at niche emergence and recognizing that a niche which is actually not orthodox ecological thinking either. The typical ecology textbooks would mention that you have a niche and you partition it into smaller and smaller spaces, and no two species can occupy that same space, but there's kind of this fixed niche space. And so maybe the trees there'd be speciation events in order to occupy different parts of that niche, but that it's more of a static quantity. And our recent work is looking at niche as a dynamic emerging thing, and that actually as one thing gets entered into the system, it actually has the opening for more things to get established, right? So it's more of the combinatorics that are going on there. The example we used in the paper was that no one would have ever invented the mouse pad 40 years ago because there were no computers and no mice and more.
Right.
And so that industry brought about other ancillary industries, and so it's this niche emergence. So anyways, that you would have a healthier system the more of these niches and roles that you have, which then also brings me to one of the more enlightening metrics that we have, and this is what Bob Ulanowitz and others have been working on, is this robustness indicator, or it goes by different names, but it's a way of measuring that diversity and that redundancy in the system versus the efficiencies in the system. And so two key properties are, how much buffer and redundancy does it have, but also it still has to get work done, and it has to be efficient, and it has to not be replaced or obsolete. And so what he's found in the studies of ecosystems was that they're not, for one thing, driving just towards more and more efficiency. That again, evolutionarily, what we see, at least in ecosystem scale dynamics, is that they are observed to reside in a space that is balancing the trade-offs between the efficiency and the redundancy, and in fact, maybe a little bit to the redundancy side of that split. And so again, we think that that's a healthy approach, that we can measure the network flows in social economic systems, and we can assess, are they overly redundant, are they overly efficient, and speak to the design of the network that way as well.
Yeah, see, again, isn't that the paper that he published? He, instead of calling it robustness, I think he originally called it ascendancy, but that was a hard word for most people.
Right,
and he
right.
published it under the term the window of vitality, which I think is very catchy myself.
Exactly. Yeah, window of vitality was the book that he had described it in a more catchy way. Ascendancy was actually the measure of just the efficiency of the network. So as it ascends, it becomes more efficient. And he developed a very complex, beautiful theory using information approaches and networks to measure ascendancy. And then when he looked closer at the data, realized that they weren't actually just maximizing ascendancy. They were maximizing this other thing, which was the trade-off between ascendancy and its redundancy essentially. So that kind of forced them to change gears a little in a very good way. I think we all agree that that's a nice, this window of vitality then, yeah, is an elegant way of describing some of the trade-offs that are necessary.
Well, and my background is in nonlinear dynamics, so I see it very much as a fractal, because it's basically that hierarchical branching pattern where you have a few big guys, more medium-sized guys, and a whole bunch of little guys. And you see that pattern whether it's, river deltas or ecosystem predator and prey relationships, but it's also in leaves and lungs and and actually you see them in economies too.
Yeah, definitely.
And so we've had some luck applying it to economic ecosystems, where you see that if you have too many big guys, it's pretty much the same as having too many big predators in your ecosystem. The imbalance is gonna wreak havoc on the system as a whole.
Right. There'll be no periphery. There'll be no the small scale activities going on because they just suck up all the resources.
Right. Exactly, which is very relevant today.
Yeah. Yeah.
Anyway, okay. So you also have measures that include what seem to be like cultural aspects, such as degree of mutualism, extractive versus constructive activity, and adaptability. How do these fit into a network analysis kind of thing, and how does your usual methods apply here? Okay.
This idea of measuring mutualism in a system also grew out of ecological studies, where there's, as you just mentioned, if you have a predator-prey relationship, and a lot of ecology is based on trying to understand who's eating who and what that relation is. And whenever you take out any two things of an ecosystem, one is likely eating another one, and you label it as a predator-prey relationship, and you kind of move on from that. And what the network approach allows you to do, though, is to see the indirect relations that might exist. So while the lion is preying on the antelope is eating the grass, and it turns out that the grass and the lion have a mutualistic relationship. They both need each other, right? So there's this indirect or cascading mutualistic relationship. And so what was again discovered by looking at the larger scale ecological models is that there's actually a lot of mutualisms out there. I mean, we've all been trained and read in tooth and claw ecology, from the Nature Channel, that it's all about just eat or being eaten, but all the other things in the background tend to be mutualisms. And so we've actually developed a theory and have this ways of measuring what we call like network mutualism, which is when there are actually more mutualistic relations than competitive relations, and it's a dominant thing we observe in ecological systems, that there really is. I mean, not it's not universal. It's not but it's in many of them there's more mutualism. So the idea then is like, well, what's going on in these economic systems? Do they show a lot of mutualism as well too? And so we take the flow data from an economy or from a trade network, or and so far the evidence is that they're not as mutualistic as the ecological systems. And so we're still trying to figure out, are they just not designed well, or the flows, not the right numbers? How do you affect that? It's hard to go to a decision maker or manager and say, well, we need to change your trade flows because we think our mutualism index will go up if you don't export as much to that other country, because of course they have a different motivation on why they're exporting or importing or trading or whatever. But still, it'll give you some insight, okay, is this a mutualistic network or not? So that's an example of really trying to dig into the indirect processes. This one about extractive versus constructive is harder to get at, but I think really key, because anytime there's going to be a flow, like on our flow networks, there's going to be the flow had to originate from some storage, from some capital, some natural capital or something, social capital. And if you're taking that flow and you're constructing another gradient with that flow, you're basically reinvesting it right away into another thing. That other thing then can be used later, and so it's more of a stair stepping of the resource. And so again, it's basically kind of a cycling there. And so we would consider that constructive, like you're using a flow, but you're using it to build something. You're actually investing it in something productive. An extractive use of that flow would be, just lighting it on fire, cutting all the trees down, deforesting it, sure, you've got a big profit, but you haven't reinvested in anything other than your own bottom line, and then you go off and, whatever, some other, orange juice futures or something like that. But yeah, so what I actually think would be useful is if we could find a way to recognize and to measure, all flows are not equal. Some, even though in the GDP sense, in the dollar sense,
yeah,
they all have the same currency, but some flows are really just, exploiting the system. Other ones are actually investing back in and constructing something in the system. And I guess a kind of an ideal approach then would be to have different investment strategies, have different even I don't know, tax regulations. If all you're going to do is cut all the trees down for your own benefit, then that you're going to be taxed at a higher rate than if you're doing something that's actually regenerating using a flow to regenerate something or to reinvest in something. So, but the first thing is to really be able to just say confidently, okay, that flow is an exploitive flow, that flow is a constructive flow. And that's a methodological thing that is not been cracked yet, but I think we have some candidates for it. But that's one of the ones in our paper that is probably more speculative, like knowing that it's important, so we put it in there, but not having the concrete measure to get to it. So anybody who's watching and wants to work on this stuff, that's a good research project.
Well, actually, one of our other rare members is got a group that may be interested in funding some pilot projects on method development and applications and things. So that would be nice.
Yeah, sounds good.
Anyway, what about adaptability?
Yeah, so adaptability comes to the adaptive cycle, right? So they're going to, a different scale. So ecosystems and biological systems have this great feature that they can adapt to things. Obviously, humans are biological, and we even have greater capacities, I think, to adapt in many ways. So just being able to be responsive, and in that sense, it's again, recognizing what's coming next and trying to see yourself on this adaptive cycle. Are you in a growth stage? Are you in more of a conservation stage? Is collapse coming? How do you reinvest? And so yeah, it's the awareness of where you are in the cycle and how to be adaptive to the next stage.
That seems very human specific as opposed to ecosystems.
Ecosystems, the anticipatory part of it, you could say, is largely more of a human feature that we have. I mean, when it happens in ecosystems, it happens probably more out of instinct or routine than anything.
Yeah, they've already been evolved
for the winter. We see that, and we don't attribute the active consciousness to the squirrel that it's clever enough to understand that, but we don't know, how the rest of the nature thinks either, right? We have to view
That's
it through our domain, but
okay, last question, just to open things up. How do you think this kind of work or these kinds of measures change the way we understand systemic health in societies?
Right. So I think they can ground it in energy network science and ground it in the first principles that we've talked about. They can also reflect it back to nature and what's worked well there. I refer again back to like eco-mimicry and just having, it's even broader than that in the sense of, I'm one of the courses I'm teaching now is we have a reader that's about eco-literacy and about how to bring this more into the educational system, and that every student should be able to leave school with ideas about energy networks and but other ecological principles too, because that's where where it comes from. And so by bringing ecological principles into the social setting, I think that already has benefits there, and I'm hoping that only gets stronger through these efforts. But then, of course, the reverse benefit, I think, is that these network properties that we have are giving you insight that weren't available otherwise to these kinds of systems. And so, being able to manage them better, I kind of said, jokingly about how the actual decision maker might respond to this, but that's again one of our research questions is can we work directly with somebody and have them manage a system differently because of, and then of course monitor and test the results to see that had a better outcome than otherwise. So yeah, I mean, our goal is to make healthy, sustainable systems, and believing that these regenerative properties are, having been taken from ecological observation and knowledge, could be informative for the rest of the planet as well too. So
okay, I'm going to leave it at that because we're sort of out of time. We're trying to keep it to 30 minutes, but
okay.
I have a slide of your, whoops, let's see. I have a slide of the top 10 things. Anyway, so I'm going to, let's see, there it goes. Just so people can see that we've broken it down into regenerative circulation, which has cross-scale circulation, reliable inputs, healthy outputs, and regenerative investments. Resilient structure, which has a balance of sizes, which is what the efficiency versus the resilience kind of thing is. Efficiency versus resilience, number and diversity of roles, and the cultural factors, the degree of mutualism, collective learning, and well, that's really adaptability, and the degree of mutualism.
Yeah,
anyway,
that could be on there. That'd be great. I see that slightly different than the one that was used in the paper, but I like that one better.
Okay.
So that's
good.
That's a good. Just because like labeling them as cultural factors, I think we called them relationships and values or something. And,
yeah.
So yeah, I think it'd be very useful if that could be flashed at some point.
Okay. Well, hopefully it's being flashed right now.
Oh, great.
Can you not see it? I take it.
No. I see it. I thought you would superimpose this because this is more like background.
No.
Dialogue.
This is it.
Forefront figures and background dialogue, but it's all being recorded. So great. Yep. Yes.
Okay. So I really appreciate your time and your effort and on the work you're doing. I think it's really important.
Okay. Yeah. Well, I appreciate having the chance to talk with you about it and also working with you as a collaborator on these topics. I enjoyed
That's
that.
True.
Look forward to more of it. So.
Hopefully. Yes. All right. Take care.
Okay. You too. Bye now.